widespread, awesome work. Is there questions? Oh yeah.
Hi there. Do you see any connection between insulin, oxygen, and the immune system?
So I'm a fake immunologist. I'm a molecular biologist trying to become an immunologist through my postdoc. So I haven't studied the immune system that deeply. Can I open up to any of my collaborators that are real immunologists?
Insulin.
And I'll give you a sheet of paper with some information on it later. Here.
Fantastic. I should read about it.
Other questions? Oh yeah.
Was the CR5 receptor involved in the controversial CRISPR baby experiments? Or
Oh, that's a great question. Yes, it absolutely was.
Was it CRISPRing off the genome inside the cells?
So essentially what you just brought up is, okay, I'm just going to say it, this psychopath rogue scientist in China who decided to CRISPR human embryos and have them born as babies. No, the technology is not far along enough for that. I think that was horrible. He's in prison, so goes. But anyway, what he did was CRISPR the embryos of their CCR5 so that HIV could not infect any cells that populate that body because the dad has HIV, because that makes sense whatsoever. No, it does not. However, I am all for a population of individuals born without CCR5 for this particular reason, so go him a little bit for trying to be a pioneer, but not this way. So when the babies were born, it worked in some, it worked not in others. And I can tell you, because I used to be an embryologist in IVF at UCSF, so I used to make babies for a living. So I know a bit about that. So you can CRISPR, or you can deliver any gene editing technology or anything you want, and the embryo divides to 8 cells, which divides to 64 cells. Pretty fast, and it's beautiful to watch. But there are so many mosaic cells within that single embryo. So if you CRISPR a cell that happens to become the entire blood system of that individual, great, it might work. But if you don't, then it's not going to work at all. And from what it seemed like, there were multiple couples involved in this, and they had no idea, by the way. And one baby was born with CCR5 negative on their CD4 T cells, and the other wasn't. So, yeah, the technology is not quite there yet, I would say.
You mentioned that the cases simultaneously had HIV and cancer. What correlation is that? Like, how strong was that correlation? And is that just a freak accident?
So HIV does not directly cause cancer in CD4 T cells. The cancer was in a different cell type. The other human retrovirus, which is called HTLV1, does directly cause cancer of CD4 T cells. So in about 5 to 20% of people who get HTLV1 will develop ATL, so the T cell lymphoma. However, it takes 40 to 50 years, so it's a really slow process. So while HIV does not cause cancer in the cells it infects, there is certainly a higher level of cancer in people living with HIV because of the catastrophic damage to the immune system from getting infected initially. So I think some ways to mitigate that are early treatment. So the WHO used to say, okay, when people have 200 CD4 T cells per ml of blood, they can receive their therapy. That's AIDS already. So you can imagine the havoc wreaked to the immune system in that time. But now it's test and treat. So as soon as you test positive and you have access to therapy, which is always a problem, but as soon as you have test positive, get access to therapy, get on your meds immediately, that also prevents the size of that reservoir. So you can imagine if you've been living with HIV for 5 years, you have a lot of time for a lot of cells to get infected, and that reservoir could be big. So if you start smaller, there are probably, we don't have the long-term studies on these early treatment studies, but I would envision that they would have lower morbidity and mortality for the aged population living with HIV.
is more like required for T cell, survival and replication. But in your scheme of things, you use IL-15. So is there anything specific on IL-15, and can we use IL-2 as well?
Yeah, so I basically have IL-2 in all my cultures already just to keep the cells alive. So we do need IL-2 for the T cells to stay happy. The IL-15 has this extra function in the proliferation and cytotoxic capacity of the CD8 T cells anyway.
But in vivo scenario, actually you are delivering like IL-15. With your nanoparticles, you
Yep.
are delivering IL-15.
To the CD8s, not
yeah,
the CD4s.
exactly.
Yeah.
So, have you ever tried like IL-2 plus IL-15 combination, or maybe IL-2 alone? Yeah.
What's that? There's a bispecific or a bi-antibody now that's IL-15 and is that IL-8? Yeah, IL-2. Yeah, so it's a super agonist again, and they've put both. To me, an antibody is a Y I'm still learning.
Could you maybe explain what IL is in terms of what you're just talking about? Interleukins? Okay, just. Interleukins.
I have a question about the clinical trial. I'm sure it's a clinical trial, so you don't really probably know, but what's the approximate timeline for once you reintroduce the cells? Is it like months, years before they potentially start seeing?
So this is the first safety trial because, of course, in order for those now robust immune system to see anything, we have to also do something to wake up the virus. So this first trial doesn't have that like lightning bolt shocking agent to wake up the virus. That's because there isn't a good one yet that won't kill the person. But essentially, we look, I think it's every week we draw blood after that, and just in a few months would take them off their therapy to see, not in this trial, but in future trials, take them off their therapy. But there's a lot of virological assays we can use first to look at HIV DNA levels, their proviral loads. So if we see that those have dropped and we can't detect it with our assays, then it's a really good informative reason to take them off their therapy. Time-wise, I don't know. I think there has to be actively replicating virus for any of these to maintain or to be continue to be stimulated. So we don't have a specific collaboration in Africa, but I know that a lot of our collaborators are working in South Africa with these broadly neutralizing antibody trials, a vaccine trial that unfortunately just failed. But we do, we work on a youth community capacity there. So my boss went to Botswana last year and essentially started this HIV Cure Academy through the International AIDS Society. And because of that, he was a keynote speaker at our big international AIDS conference, and we created this capacity to fund youth in training programs for HIV cure in their communities. So we had 4 grantees in Kenya, Uganda, South Africa, and Botswana this year, and we're already starting the one for next year. So we're starting to get more involved in these communities. And for example, Lish's lab, they work a lot in Thailand. Any more questions?
Great. Another round of applause. So we'll take a short break.